And we'll go ahead and pull up our handy dandy whiteboard. First of all, does anybody have any questions as far as my last
No,
I'm gonna wait till she gets fixed because her microphone is extra. Miss Bowman, your microphone is like ultra sensitive. Okay, so I got you muted for right now. Hold on, just might want to turn your microphone down a little bit because it's like you moving your book bag around. Hold on. You were like moving your book bag around. It sounded like you were blowing up or something, like a stick of dynamite went off. All right, so. Yeah, it sounds a whole lot better. You there, Miss Bowman? Can you hear me?
Yes.
Okay, all right. So, it ain't as bad as one time I let somebody Skype in for class and they were having a fight with their boyfriend, and they just let everybody hear it, and it was just, I had to mute it. So, when you're Skyping with a class, don't have a fight with your boyfriend, okay?
All right.
Oh, I'm talking about everybody. I mean, the whole class heard it. Okay. Now, did anybody have any trouble getting online? Did anybody have any trouble getting on My Labs Plus? Okay, good. Then everybody should be ready to start homework, which I will start now, and we'll start with 5.1. I'm hearing all kinds of noises. Miss Bowman, I'm going to mute you because evidently, if you have a question, just type it in on the what do you call it? The chat down at the bottom of the page, okay? Or just wave your hands like this or something, okay? All right. Yeah, we still got the Oconee campus. I didn't mute you, did you?
No, I don't think so.
Y'all just don't want to talk to me. Okay, that's fine. All right, so here we go. If I ask y'all to factor 54, what would you say if I asked you to factor 54? What would you say? Okay, that means that's not rhetorical. I want y'all to say something back to me. If I asked you to factor 54, what would you say back to me? Factor means break up. Break up into multiples. So multiples mean that we're going to multiply to get the number, right? Multiple means multiply. So now let me go back. What if I ask you to factor 54? What would you say? Six times 9. 99% of the population will say 6 times 9. Although there'll be a little mousy fellow in the back going, well, there's also 2 times 27. Okay, people like that need a life. Most people, 6 times 9, all right? 6 times 9, that's the multiplication table. Multiplication table, you break up 54 into 6 times 9. All right? I have just broken that up into 2 composite numbers. 2 composite numbers. What does composite mean? Anybody want to take a stab at it? Composite numbers mean numbers that are made up of other numbers. Numbers that are made up of other numbers. Numbers made up of other numbers. Well, Hubert, all numbers are made up of other numbers. Not necessarily. You got some numbers that are made up with composite numbers and some numbers that are made up of prime numbers. So what are composite numbers? Well, composite numbers are 4, 6, 8, 9, 10, 12, 14, 15, 16, and so on. Now, why are those composite numbers? Because they're basically the complement of prime numbers. Prime numbers are only divisible by themselves in what? 1. Good job. Somebody paying attention or read. All right. Prime numbers are numbers only divisible by themselves and 1. I was thumbing around the remote last night, and I ran into a mini-series, or I guess you call it. Anybody seen Sharp Objects?
Nope.
No.
Okay. It's a HBO mini-series about this girl that carves herself up because she had a black past. You know how people carve their skin. Don't forget it. Anyway, it's pretty good. Y'all never seen it before?
What are you watching?
It's a. You just have to watch it. Google it and look it up. I don't know. I don't know how to.
I'm scared to.
Huh?
I'm scared to Google it.
No. It's nothing like that. You're thinking horror movie. No, it's a thriller. It's a movie. It's a mystery
What's
type.
the difference?
Okay. There's this girl. She is a reporter. She grew up in a small town in Missouri. And she's a reporter now. And she had a very black, dark past in this town. Her mother was very aristocratical. She lost her sister. And she's losing her half-sister. And basically the mother is one of these people that like to make their children sick to get attention.
Oh, yeah. Mm-hmm.
So she killed the sister. So she killed her younger sister. And after she killed her younger sister, she went crazy and started carving names into her arms and her back and her legs and everything. So it's called Sharp Objects. It's called Sharp Objects, and it's about her finding out about the murder of her sister. And that's about, oh well. It's a psychological thriller type thing. No slash, no blood, no blood and guts or anything like that. But anyway, it was, okay, you know who played dang old Lois Lane in the dang old last movie, Justice League and Superman Dead and all that? The red-haired girl? That's her.
Yeah.
Amy something.
Adams?
Yeah, Amy Adams. She's the main role. She did a real good job. It's a pretty good mini-series / movie. Dang, I watched 8 episodes of that thing yesterday. It was really good. It was on HBO. Okay. What does that have to do with this? Absolutely nothing. I told y'all, sometimes I chase rabbits, and that was a rabbit just crossed the road. I'm sorry, but I chase rabbits every once in a while. All right, so anyway, give me a list of numbers that are only divisible by themselves in 1. Okay, it's the numbers that are not up here. 1, 2, 3, 5, 7, 11, 13, 15, no, 16, no, 17, 19, and so on. Now, I'm going to highlight these because we're going to use these later. Those right there. I used to call them the ugly numbers, but since everybody gets so offended these days, I don't use the ugly word. I use non-attractive numbers, okay? Non-attractive numbers means that, what would you rather say is the factor of 54? 6 times 9 or 2 times 27? 6 times 9 is a whole lot easier to deal with than 2 times 27. Why? Because 2 times 27 is kind of ugly. All right? And you don't want to think of things in terms of 2 times 27. You want to think of terms of 6 times 9 because that's the way we were educated. We were educated to follow the multiplication tables. And that 2 times 27 is not a multiplication table. So that's why we stick to the 6 times 9. Now, that's why the composite numbers are the ones that we kind of tend to flock to. All right? We kind of, it's kind of like when you can speak several languages. All right, not many people can do that because not many people are smart enough to speak several languages. I'm not. Okay, so I consider somebody that can speak 5 or 6 languages to be very, very smart. Okay, because they have to discern between the two. Now, what the heck does that have to do with this? Well, you have 2 languages here, Spanish and English. Is there a preference for somebody that knows more than one language? Yes. Usually when somebody knows more than one language, they like to tend to use that language. Same thing here. We tend to hang around these guys. Why? Because they use them more and they're easily available. You don't have to think too much. Okay? 3 times 8, boom, 24. 2 times 12, hold on a minute. You don't like 2 times 12. You like 3 times 4 or 2 times 6 or whatever the case may be. All right? The whole point is you kind of generate toward these numbers, and these numbers are considered to be outcasts. You see what I'm saying? So which one I want you to work with in Unit 1? I want you to work with the outcasts. I want you to work with the prime numbers. Because my goal is to get you to do one thing in this unit that a lot of people can't do, and that's deal with fractions. Okay? And I've been teaching Math 155 for a long time, and out of everything in Unit 1, that is the one problem that people have, and that is fractions. They have no idea what they mean. They have no idea how to add them, how to subtract them, how to multiply them. They don't know anything about them, and all because they don't know how to find the prime factorization. All right, that's how you find the common denominator. You find the least multiple. So we're gonna crawl before we can walk, and we're gonna go over the prime factorization of numbers first, then we're gonna go over the least common multiple, then we're gonna go over the common denominator. And then when I get through with 5.2, 5.1, and 5.3, we're not worried about 5.2 right now. 5.1 and 5.3, you will be able to do. If you haven't been able to do before, you will be able to do adding and subtracting the fractions. Okay? Questions so far? All right. So let's take a look at a number and let's break it down into the prime factors. So I'm going to go with 54. And I'm going to draw a little grid right here. And I'm going to put up here 2, 3, 5, 7, 11, and sometimes 13. There's my numbers, and this is the same thing I'm going to do every single time from here on out in Unit 1. I'm going to use that little cross, and I'm going to put 54 at the top of it, and I'm going to go through and use those numbers to break it down into prime factorization. Well, Huber, I thought we already factored it. We factored it into the composite numbers. Okay? 6 times 9 is both composite. That's not what I want. I want prime factorization. That means I've got to have it in terms of those 5 or 6 numbers up at the top. So, start with a number. I don't care. I usually start with 2 or 3 because not many numbers cannot be divisible by 2 or 3. So I'm going to start with 2 because I like 2's. So I'm going to divide by 2, and that'll give me that 27 I was talking about. Now what number can we use? Well, you know your multiplication tables. What number out of the top 5 or 6 numbers will go into 27? That's not rhetorical. I want y'all to tell me. What numbers, 2, 3, 5, 7, 11, 13, will go into 27? 3! Miss Bowman, I tell you what, she's smart. She knows she can't talk, so she just puts up a 3. Thank you, Miss Bowman. Appreciate the interaction. 3 will go into 27 how many times? 9 times, Hubert. Thank you, Oconee campus and Anderson campus, for the interaction. Now, what will go into 9?
3.
3. Thank you. And what will go into 3?
3.
When you get this 1, you're done. So now we take our handy dandy highlighter, and now we highlight the left-hand side, and that is your prime factorization. So the prime factorization of 54 is equal to 2 times 3 to the what power? Third power.
Third.
All right. Now, we're going to do like 15,000 of these. So let's do another one. All right, you do that one. First of all, 2, 3, 5, 7, 11, and sometimes 13. Y'all do that one. And if you can't do it, if you get stumped, we'll just write it down as a failure. That means that you're a failure, and you should probably quit school. Y'all need to liven up. I told y'all to get a Mountain Dew and bring in here. Y'all need to get a Mountain Dew. Well, Hubert, I really don't like Mountain Dew. Well, you need to bring some coffee in or something. Okay, I'll do that. Okay. Now, one good thing you can see about 144, what's distinctive about 144 that you can say, oh, I know what goes into that? Say again? 2. Miss Bowman said 2, I think. So, how do you know that? You know that because it's divisible by 2 because it ends in what?
A 4.
It ends in 4. Let me show y'all something. And a lot of people I show this to and they go, oh my gosh, I didn't know that. Just consider it that you didn't get your money's worth in elementary school or you didn't listen, one of the two. Or both. Let's go with Visibility rules. And hit images. Oh my gosh, look at there. Isn't that nice? You need to make yourself a note to Google that, print it out, and put it on an index card if you don't know it. And I guarantee you, let's see, there's 1, 2, 3, 4, 5, 6. There's 5 of y'all up there, right? 6, 7, 8. There's 8 people in this class. I guarantee you that half the class probably has never seen that before or they have forgotten it. So you need to Google it, the visibility rules, and then you need to read it. And you need to put it on an index card or the front of your notebook or the front inside cover of your notebook so you can remember. Now, a lot of people know the 5s and the 2s, but it's the 3, the 7, the 8, and the 9 that people don't know. Okay? Now, of course, you don't need to know you need to know 2, 3, 5, 7, 11, and 13 is not on there, but that's it. You're welcome. So anyway, let's get back to what we were talking about. So we decided that we can divide that by what?
2.
2. Thank you. Dang old guided lecture, dang old interaction. 2 will go into 144, 7, and 2. Oh my gosh. That's a dadgum times table. 72. But we don't have a 6 times 9. We don't have that. But what will go into 6 and 9?
3.
3. So we're going to divide 3. You can divide 2 into it. That's fine. 2 would be in 36. But the reason I did 3 was because I'm going back to my multiplication tables of what? 9 times what? 8? Yeah. And 6 times 12. So 9 and 6, what goes into 9 and 6? 3. So it's divisible by 3. So 3 will go into 7 2 times. That'll leave a 12. Okay, what else? How many times, what goes into, give me a number going in 12. I mean 24. What number?
2.
2, that gives me a 12. What number goes into 12?
3.
3. That's 4. What number goes into 4?
2.
And what number goes into 2?
1.
And now we have the prime factorization. So count your 2s. Let's count our 2s. 1, 2, 3, 4. So that's 2 to the 4th power times 3 to the what? And that's the prime factorization of 144. All right, let's do a nerd. How about 69? 2, 3, 5, 7, 11, sometimes 13. All right, go to town. We finally included you, Miss Bowman. The feedback, I think you turned it down enough. Now I'm not hearing myself talk. She still ain't coming in. I wonder why she still ain't coming in.
It was on mute.
What?
It was on mute.
Ah, okay. Well, just mute it and, well, I don't hear anything. I don't hear myself talk, so I think we're okay. But you can leave it on mute until you have a question. It's whatever. Okay. Usually, and that's because it happens whenever somebody Skypes in, because these 3D cameras, they're all about the same, but some of y'all's microphones that y'all have internal on your laptops, they're extremely sensitive, and whenever you move a book or open anything, your book bag or whatever, it sounds like the whole building's falling down on top of it. So, what number would you hypothesize go into 69?
3.
3. Good job. Because it ends in 9. 3. That'll be a 2 and a 3. What's 23?
1.
A prime number. So you're done. Prime factorization of 69 is 3 times what? 3 times 23. Because what number goes into 23? Nothing. 3 won't go into it. 2 won't go into it. That's it. You're done.
Sure. Thank you.
Okay? Now let's do a nerd. How about 243? That ought to discourage some of y'all. 2, 3, 5, 7, 11, and 13. That's my job, to get y'all to quit. So hopefully 243 will do it.
Three.
3? Well, let's see. Yep, it ends in 3, so chances are 3 will go into it. 3 will go into 24 8 times. and 81. Now, what number will go into 81? That's rhetorical, I'm asking y'all. Okay, well, I'll go sit down until y'all decide to talk to me. What number will go into 81? What number goes into, what number, what's the first number you think of when I say 81?
9.
3 can go into 81.
What number goes into 9?
3.
So if 3 goes into 9 and 9 goes into 81, then 3 goes into 81. Dang old logic. 3. How many times will 3 go into 8?
2.
And what's left over?
27. Oh, 7. Yeah, 7.
21, which is 3 will go into 21 how many times? 7 times. Now what will go into 27?
3.
3. And 3 will go into 9. And 3 will go into 3. And here is your prime factorization. 3 to the what?
5th power.
3 to the 5th power. Okay, mute, Miss Bowman.
Sir?
Mute. We got all kinds of feedback coming on this end. Thank you.
You're welcome.
All right. Okay, let's do a narrative. How about I don't know what that noise is. 2, 3, 5, 7, 11, and sometimes 13. Yeah. All right, so tell me what number you automatically know goes into this one without even thinking.
5.
5. Why? Because it ends in 5. So start with the 5. 5 will go into 625 125 times. 5 will go into 125 how many times? 25 times. 5 will go into 25 5 times. 5 will go into 5 1 time. So 5 to the what? 5 to the 4th power.
5th power.
Huh?
No.
4.
I'm sorry. 3rd
It
power.
should be 4.
4.
Unless I made a mistake. Now, I guarantee you somebody in here has never seen this before. If you've never seen this before, then there's no way you can do the least common multiple. And if you can't do the least common multiple, then you can't do the common denominator. Okay? A lot of people get by with doing the common denominator by memorizing the common denominators. But sometimes you can't do that. And then they end up multiplying them together and they have to use a calculator because the number is so big that they have to use a calculator to try to do it, and they end up quitting the problem. Okay? Learn how to use this method. Give you one more. I'm trying to think of 1, 2, 3, 5, 7, 11, and sometimes 13. Just give me a second, I'm multiplying. Try 2,424. I've given you enough information in 5 or 6 examples, or 5 examples, so you can do that 6. Say again?
2.
Well, yes, we'll start with a 2. Now, why did you start with a 2, Miss Bowman?
Because you can divide 2 by 24.
Yeah, and it's an even number. So 2. And so you can also work on your mental division. 2 will go into 2 one time. 2 will go into 4 2 times. 2 will go into 2 one time. 2 will go into 4 2 times. All right, keep it up. I want y'all to work on it on your own and see what you get. So what goes into 12 12?
2.
2. So that'd be 2, and that'd be 6. 6 will not go into 1. 6 will go into 12. How many times?
2.
602. Mute. Sounds like I'm listening to the news now.
What if you did it with a 3?
Wait a minute, that's not, I believe that's my phone. Yep. Sorry, my phone's going on. Some crazy guy talking about math class.
Wouldn't that be 606 instead of 602?
Yes, thank you. I think somebody said something from the Easley campus. Yeah, I make a little mistake and everybody talks in. That's okay. That's fine. All right, now 606. 2 will go into 606. How many times?
3.
3. What?
3.
Now what? What will go into 303?
3.
3.
3.
1.
And then 101.
0, 1. Is there anything that will go into 101? Well, 3, but that'll give you an 11. That won't work. 5 won't work. 2 won't work. 7. 7 will give you a 31, not a 21, so that won't work. 11. 11 times 9 is 99. 11 times 10 is what? 110, so that won't work. 13 won't work. Let's see, 7, 8, 9. 7's the only one that will work. 7 times 3 is 21. That gives you 91. So it looks like to me we're done. What'd y'all come up with?
Instead of 606, I did a 3.
Yeah, that's what I did too.
What?
I divided 3 into, I divided the 24 by 3.
606 divided by 3.
Okay, but you should have 4 numbers on the left and then 101 or 4 numbers. What do you have? You had 2 to the third power times 3 times 101?
I got 2, 3, and 4.
I mean, I got the answer, but I
How do
didn't
you
get
have
it.
2, 3, and 4? We don't have a 4 up here.
I did 24 divided by 2, then 12 divided by 3, and then 404 divided by 4.
Where'd you get the 4?
I used the other numbers.
Oh, you decided to use another method. Okay.
Yeah, I understand how to do it, but I just did it that way.
You didn't follow simple directions is all there is to it. Okay,
Correct.
just leave. Just leave. Just get out of my classroom. All right? You can't use 4. 4's what? 4's not in here. We're using what kind of numbers? Prime numbers. All right, so what did you get when you used all prime numbers and didn't use your own mathematical method? All right, what did you get? You're tough, you can take it. All right, 2 to the 3rd power times 2 times 101. What'd y'all get?
2 to the 3rd power times 3 times.
That's supposed to be a 3, sorry. Now, somebody take your calculator and multiply 2 times 2 times 2 times 3 times 101 and see if you don't come up with 2424. The whole point is that you got to use the prime numbers, okay? You can't interject another number in there. You have to use, now you could use 15, but 15, most of the time, I'd say 99% of the time, those 6 numbers will divide into the number you want. 99% of the time. Unless I put some crazy A number up there, most of the time, those 6 numbers will divide into them. Okay? Now, let's talk about 2 numbers, add 2 numbers on here. All right? Let's go with something real simple. Let's go with 6 and 12. What the heck are we going to do with these? Well, the magic is you want all 1s on the bottom. The only numbers you can use are 2, 3, 5, 7, 11, and sometimes 13. So let's divide by 2. You can divide by 3 if you want to, it doesn't matter. So divide by 2, and I get a what? A 3 and a what? A 6. Now I'm going to divide by 3, and I get a 1. Hey, that's good. That's what I want. I want a 1. I want 1s all the way across. But what happens here? Why do I draw a longer line in red right here? Because the real math stops. When the real math stops, you have found a number. And that number is the least common multiple. Now, I may have it backwards because I always get it confused ever since college. Least common multiple is the largest number that will divide into 6 and 12. What's 2 times 3?
6.
So what's the biggest number that you can divide into 6 and 12?
3.
6.
I just told you, 6. Will 6 go into 6? That's a yes or no question. Will 6 go into 6?
Yes.
Will 6 go into 12?
Yes.
Yes. So that is the biggest number that will go into 6 and 12. That is called the least common multiple if I don't have it backwards. Now, I'm dyslexic every once in a while. But when it comes to least common multiple and greatest common divisor, I'm very dyslexic. I get it backwards all the time. I hope I got it right. You have to look in your book. Okay? So if I have it backwards when you do your homework, just switch it. Now, I'm going to keep on going. But I'm going to use magic math. Because my goal is to have ones on the bottom. Right now I have one of those ones right here, but I don't have both of them. So what I need to do is divide by 2, and I'll have all ones. But you got to remember, the real math stops. I'm going to use what's called magic math. Here we go. I'm going to divide by 2. Can I divide 2 into 1 and get an even number? No. You just bring it down. How many times will 2 go into 2?
Once.
One time. So I got my magic numbers, okay? 2 divided by 2 is 1. All right, so I've got my, so now I take my blue pen and I circle these numbers, and that's called my greatest common divisor. Greatest common divisor is the smallest number that 6 and 12 will divide into. So what is the smallest number that 6 and 12 will go into? Well, what's 2 times 3 times 2?
12.
12. 12 is the smallest number that 6 and 12 will go into. Now, that blue, that greatest common divisor, you need to make a note there. That is called, in the future, your common denominator. This right here is called your least common, what?
Denominator.
Least common denominator. You need to write that down because that's what we're going to do in 5.3. Right now we're in 5.1. And I'll show you an example of this in just a minute. Well, I'll go ahead and shrink it, and that way you can see what I'm talking about. Now, you don't have to write this next one down. You can do it if you want to. That's up to you if you want to write it. I'm going to shrink this down a little bit. And I'm going to show you why this is important. I know, y'all are impressed. Okay, so if I tell you, and this is 5.3, this is 5.1, so 5.3, I tell you to add 3 or 5 over 6. Let me do 5. 5 over 6 plus 7 over 12. And I tell you, I want you to add those two fractions. Well, now we know that the common denominator of 6 and 12 is what? What do we say it was?
2.
No, 2 times 3 times 2. What is that?
12.
12. So you put a 12 here, and you put a 12 here. Now this is the good part. Now this is a very simple question, but problems that you're going to be doing 5.3 for me are going to be god-awful difficult. All right? They're not going to be easy because I'm trying to get you to see something. All right, look at here. Where is 6? 6 will go into 12. Go over here and mark off the 6. How many times will 6 go into 12?
2.
2 times. 2 times 5 is what?
10.
10. How many times will 12 go into 12?
Once.
1 times 7? And your answer is 17 over 12. Now see, if you didn't know how to get the common denominator, then you just blew off. You just skipped all the fraction problems on a test because you didn't know how to find the common denominator. Now a lot of you say, well, I can find the common denominator of 6 and 12. Yeah, but I'm not going to give you the common denominator of 6 and 12. I'm going to give you the common denominator of 572 and 346. Okay? I'm going to give you ones that are a little bit more complicated than 6 and 12. Right now I'm showing you how we use this guy right here to find the common denominator of two difficult denominators. Okay? And we're going to do a bunch of these now. That's 5.1. We're working on 5.1 today. Okay? So let's do a nerd. How about 49 and 243. No, that's not right. That's not right. Hold on. I'm thinking. Hold on. $343. All right, take a minute and work on that. Remember, 2, 3, 5, 7, 11, and 13. 2, 3, 5, 7, 11, and 13. Now that's just like in homework, 5 over 49 plus 6 over 343. So you got to find the common denominator of 49 and 343. So what number am I going to start with?
7.
7. That'll give you a 7 here. 7 will go into 34 like 4 times. That'll leave 28 and 63 be 49. 7 give you a 1 and a 7. At this point, the real math what?
Ends.
The real math stops because there's not another number that will go into 1 and 7. Okay? So, but we're going to keep going with the magic math, and I'm going to do it red. And I'm going to say, okay, I need to divide by one more 7. And that'll come down because I can't divide 1 into 7. But 7 times 7 will go into 7 one time. So I got my 1s. So this is my common denominator of 343. So I put 343 right here. And I put 343 right here. How many times will 49 go into 343? So you go over here and mark off 49. How many times will it go into 343? 7 times. 7 times 5 is what?
35.
35. And how many times will 343 go into 343? 1 times 6 is, so your answer is what? 41 over 343. That's why people cannot do adding and subtracting of fractions, is because they never have been able to find the least common or the greatest common divisor.
Will we ever have to simplify it?
Say again?
Will we ever have to simplify the fraction?
Not if you use prime factorization, you won't. Okay, this is low as it'll go. This is reduced form. That's the whole purpose of doing prime factorization. Okay? Mr. Robinson, you awake?
Yeah, I'm waiting.
All right, a while ago, Mr. Robinson used a 4. Now, that's okay if you're just doing factorization. But what happens is, if you don't use all prime factors, that 4 will cause you to have to reduce the fraction down at the answer. Do you see what I'm saying? Because 4 is a composite number. If you stick to these 6 prime numbers, will you have to reduce your final answer?
No.
No. And that's the point of using prime factorization. They're trying to get you to see that if you want your answer in the lowest form, then you need to use prime factorization. But we don't want to use prime factorization. We want to use the 4s and the 6s and the 8s and the 10s and the 12s. We want to use those numbers. Well, you need to use both, but you need to know what happens when you use both. Yes, using the 4 and the 6 and the 8s and the 16s and the 12s, they're easier, but you have to worry about what when you get finished?
Reducing.
You have to worry about reducing. That's the double-edged sword. On the other side of the sword, you can use prime factorization, which you don't like to work with, but you already have it in reduced form when you get the answer. Okay? Comprende? Capiche? Do you understand?
Yep. Uh-huh.
Nobody's going to talk to me. Okay. Let's go to the handy-dandy homework, and let's look at a few ways you can complain about it. And pull up the handy-dandy 155. One 155, there it is. We'll just pull up the Anderson campus. And let's see, we're supposed to walk around, we're supposed to wander around and not know where to go. I don't know where the assignments are. And I don't have the assignment stuff. Hubert sucks. All right, so now I go back to my courses, and I go down to my coordinated course, and I pull up Math 155. Mute, Miss Bowman, please. Where is my coordinated courses? There it is. Math 155. Hold on just a minute, guys. And I'm going to assign my dang old homework. And section 5.1, 5.2, 5.3, 5.6. And in 10.1, somebody check the outline. Is 10.1 in Unit 1?
Yes, yes.
Thank you. Y'all are so smart. There we go. And I'm going to assign those that are checked. Update. No, don't do that. Don't do that. Don't do that. Apply. There we go. Now update. And now I go back to the main menu and go into y'all's course, which is down here. I'm going to go into Anderson. That's the one I went in last. And now go to assignments. Why didn't it show up? Okay, it should have showed up. Let me go back. Hold on just a second. That's not right. Something's not right. It's the first time we dealt with the coordinated courses, so just give me a second. Math coordinated course right there. Math 155. Course tools, assignment manager. I just assigned it. Oh, I bet I know why. But I'm gonna have to go out of it. Okay, I'll just go into a preview here. It'll do it automatically later. Let me just go into a preview. We're in 5.5, so a 5.1. So here we go. Let me find one that there we go. All right, try that. Find the greatest common divisor and the least common multiple. See, I got them backwards. I do that every semester. No matter how many times I teach this course, I do that every semester. It's the Russians is what it is. So go ahead and find the greatest common divisor. That's the one that's smaller. So hold on. Let me get here, go here, and we're doing 72 and 592. 2, 3, 5, 7, 11, and sometimes 13. All right, find the two numbers. Go to it.
Actually, it's so 5 in the center.
2.
Well, yeah, we'll start with 2. Go ahead and start on it. I'm going to give you all a minute or two to work on it. Well, smoke's coming out of everybody's ears. I'll call the roll while y'all are ciphering. Well, thought I had a pen up here. There it is. Thought the Russians got my pen too. Dadgum Russians are in everybody. All right. Josh, you here? No. Bowman is here. Carrillo is here. And Willis is here. Gilstrap.
Here.
Johnson is here. Phillips and Phillips are here. And Robinson is here. 2, 3, 5. Yeah, Phillips, Gilstrap. Okay. And today is the what? 27th?
Yes.
I'm going to take roll this week, and after that, I'm not going to worry about it that much. I'll just go through and say that everybody's here because I really don't care after. I don't really care, period, but We got some people on campus that do care. They send you emails when you're not here. I guess if you ask them nicely, they'll hold your hand and take you down the hall to the bathroom too. Maybe fluff your pillow up if you need to fluff your pillow up. Am I being mean?
Nope.
I just I'm sorry. You go in the military or college, you're an adult. I'm sorry. Okay, 2. I'm going to start with a 2. As Ms. Bowman said, why am I starting with a 2? Because they're both even numbers. They end in an even number, so 2 will go into them. Divisibility rules, print that out. Dang old 36. 2 will go into 5 2 times. That'll leave 19. 2 will go into 19 9 times. That's 18. 12. 2 will go into 12 6 times. Somebody check my math.
Correct.
Of course it is. All right.
You said
now,
correct.
what will go into both? 36. I was being facetious there. How many will go into 36 and 296? They're both even, so
18.
Okay, I'll give a $100 bill. Where's 18 up there?
Well, I mean 2 and then 18.
2. You're right. 2 times 18. Very good, Miss Bowman. You're very smart. I'm just giving you a hard time. 2 will go into 2 1 time. 2 will go into 9 4 times. Leave a 1 in your head. 16 8. Now, some of y'all are going, what's he talking about? 1 in my head. If you don't know what I'm talking about, you need to get to where I'm talking about it. Okay? You need to get to where I'm saying 1 in my head. Okay? This thing right here. 2 going to 296. 2 going. Okay. You need to be doing all this in your head. Okay? And don't let me see you use a calculator on this. I haven't told anybody to get a calculator out because you shouldn't have to use a calculator on this. Okay? And I'm not making fun of anybody. If anybody's got a calculator out, I'm not making fun of you. I don't see a calculator, so I think I'm okay. You don't need to be doing that on the paper, and you don't need to be doing it in your head. I don't know if anybody's doing it. I say this in every Math 155 course that I teach. You should be doing 2 will go into 2 1 time. 2 will go into 9 4 times. That'll be 8. That'll be a 1 left over. 2 will go into 18 9 times, or whatever the case may be. All right. 2 will go into 16 8 times. You should be doing that in your head. Some way, some form. If you do it faster than I do, great. Hallelujah. All right? But you should not be doing it longhand, and you should not be doing it on a calculator, because you need to get those things up in your brain. You need to get them firing, and you're not going to get them firing by using a calculator. Okay, 2 will go into 18. How many times? 19 times, Hubert. Idiot. 9 times. I'm sorry, I take medication for that. It's called Jack Daniels, but I haven't had any today. 2 will go into 14. How many times? 7? 74?
2.
Uh-oh. What's the problem? Real math, what? Real math stops. Why? Because what goes into 9?
3.
And 3 will not go into what?
74.
Won't go into 74. Oh, yeah, it does. 3 will go into 7 2 times. That'll leave 1 for... no. 3 won't go into 74. The only thing that'll go into 74 is what?
74.
2. Because it's what? It ends in 4. So, real math stops. So, what's the greatest common divisor?
2.
2 to the 3rd power, which is 8, Hubert. That's right, class. Now I'm going to keep going. 3 will go into 9 3 times. 74 comes down. 3 will go into 3 1 time. 74 comes down. Now we got to work on 74. So 2 will go into 74. That comes down. 2 will go into 74, what, 37 times? Yes, Hubert. No, Hubert. I have no clue, Hubert. And 37 will go in. So here is your least common multiple. So now we got to figure that. So the least common multiple is 2 to the 4th power. 1, 2, 3, 4. 3 to the 2nd power. And 37. Now I'm going to type it in, that second one as exponents, and see if it has a conniption. All right? And we'll see what the homework wants you to type in. So the first one I'm going to type in 8. And I feel good about myself, so I don't have to put smokestacks on my pickup truck. Least common multiple, I'm going to type in the exponents. 2, shift up, 4, right arrow, times, shift 8, 3, shift up, or shift caret symbol, 2, shift right, times 37. Okay, it didn't like that, so I've got to multiply it out. Evidently, it's wanting to be a number. So 2 to the 4th is what? 16? So this is going to be 16 times 27. 16 times 27. I think I'm going to do 16 times 20. 16 times 20 is 320. And then 7 times 16 is 112. And that's going to be 432. Somebody multiply 16 times 27 and see if you get 432. Somebody get out your handy dandy phone, calculator, try it. Now we got to multiply that by 37, which is going to be a pain, but we'll do it. All you got to do is just add a 0. 3, 6, 9. I got 12,960. Somebody multiply 16 times 27 times 37. No, I did 30. I'm sorry. I got to do 7. 7 times 4, 3. So 7 is going to be 4, 7, hold on a second. 7 will be 14, it'll be 22, bring you 2. 7 and 4 is 28, that'd be 30. I got 15,984. What'd y'all get? I'm sorry, what? We'll get a second. Somebody tell me what you got. 16 times 27 times 37. What'd you get?
What you got? You're right.
Of course you did. All right, so that should be your answer. A lot of people saying, what the hell did he just do? Well, I don't like to use 37. I don't like to use 27, and I don't like to use 37. Why do I not like to use those numbers? Because they mess up your brain. So what I did is I multiplied 16 times 20. And then I did the 7. I did that in my head, and that way I didn't have to do times 27. And then I did the same thing with the 37. I multiplied it by 30, and then I multiplied it by 7, and then I added the 2. That way it's a whole lot easier, because everybody can multiply by 10. So, and hopefully 984, I feel good about myself, so I don't, oops, no. I must have something wrong. Anybody get another answer?
No.
Correct answer, 53. Okay, I did something wrong. So let's do it again. Let me do it again because evidently I did something wrong. And I want to make sure I don't mess up again. So let's do it again. Let's go back and I'm going to do it again. Because you will find out that when I do things like that and I make a mistake, I will do it over 3 or 4 times to find my mistake. So here we go. 2. 2 will be 36. 2 will go into 5 2 times. That'll leave 19. That'll be 9, which will be 18, which will be 6. Make sure I got that right. Okay? I think that's right, because 2 times 300 is 600, so that should be right. 2 will go in there 18 times. 2, 1. 2 will go into 9 4 times. That'll leave 1, and 16 will be 8. Somebody check that for me. 296, yeah. 2 will go into 2 1 times, 2 will go into 9 4 times, that'll leave 16, 8. Okay, 2 will go into 18 9 times, 2 will go into 148 74 times. I think I've done something wrong. No, I didn't. Didn't I get 9 and 74 a while ago?
Yes.
Okay, 3 will not go into 74. Because that'll leave 14, and 3 won't go into 14. 2 go in there 2 3 times, that'll be 6, 14. Okay, that's where I went wrong. But 2 won't go into 9, so that's okay. So that's it. That's it. So 8 is the answer. Now I'm going to keep going. 3 will go in there 3 times. 3 won't go in here, so 3, 2, yeah. So bring that down. 3, 1, 74. 2, 1, and 37. And 37. 1 and 1. That should be it. Is that not what I got? 2,
Yeah.
1, 2,
That's
3.
what you got.
2 to the 4th. 2 times, wait a minute, that's 16. 3 times, that's, I think I did 27. That's it, right here. I did that. 3 to the 2nd power is not 27, stupid. All right, so that's where I wrote the right answer down. I just had a brain bubble right here. So that's 3 to the 2nd power. So I did it right the first time. I just wrote, okay, let me go back. That's 16 times 9 times 37. Okay, and I did, okay, I'm going to do 16 times 37, but I'm not going to do, I'm going to do 10 times 37, which will be 370, and 6 times 37, which will be, 6 times 3 is 18, 222, I think. Somebody check 16 times 7, please. I think it knows. Let's see. Yeah.
112.
Is it 112? Okay.
Yeah.
Okay, 112. So that's going to give me 482. 16 times 37, check it. 16 times 37 is 482.
592.
592, sorry. Okay, 592. I had it off. And then 592 times 9 is going to be 8, 2, and 8, 5, and 9. 53, 5, 3, 2, 8. Somebody check me.
Yes.
Yeah.
5,328.
Okay, so that should be your answer. Somebody have done changed. But I had the right answer right here. Is the same as this, except that when I came down here, I said 3 to the 2nd power is 27 for some crazy reason. Okay, now that's enough to quit on today because I don't want to push it. Now, what should you be working on tonight? You should be working on 5.1 homework. When you come back, now what should you do if you run into a problem and you can't answer it? Ask what?
For help.
Ask my instructor. Send it to me. If I don't see anything Wednesday, what am I going to assume? That you know how to do it. We're going to keep on going. Y'all have a good day.
You too.
Glad y'all got to see me today.